This video is for those of you who are trying to detect intersection between two round objects, two balls. One of the things you might have run into immediately, and I'm going to share this code with you, is that the intersects takes as an argument a rectangle. Okay, so you can't, there's not like a native does one shape intersect with another. It's basically does it a shape interact with a rectangle. So the sort of quick and easy way around it, we'll look at first. It's not perfect, but it will get the job done depending on how precise you need to be. What this does, this one I do ball2.getBounds. That's going to basically get a rectangle which surrounds the ball. Now, if your ball is pretty tiny, that's not going to make much difference because the rectangle is going to be pretty similar to the ball that it's around anyway. But if you have a case where you have a bigger ball, then you might get some false positives on their interaction. But this is a pretty easy way to do. So if you wanted to see if ball one intersects ball two, you can't do ball one dot intersects ball two. You need to do the get bounds of the second one, which will return the sort of rectangle around ball two. So without further delay, let's take a look at what actually happens when I do that. So I have two pretty large balls on the screen. And what you'll see is that I get the intersecting flag even when they're close. So they'll like be close calls, but not quite bump into each other. That's because it's not detecting the intersection so much with the balls itself as the rectangle that's around one of them. And it's going to be a little more sensitive than we want it to be, particularly if you're doing something precise. Now, again, you might be able to get away with it, particularly if you have much smaller objects. These are very large balls, so you can visually detect the difference between when they're not quite touching and when they are touching. But it is possible to write a more precise method to find this detection, and I've written one that you can feel free to use. So I'm going to close this now, and we're going to look at this other method which I have written, and you are welcome to use. And this is going to detect collision or intersection really based on some geometry, some analytic geometry. So I made a method called check ball collision with two balls. And in short, what that does, and it kind of looks messy, but it's really not super complicated what it's doing. It's basically, first of all, it gets that the radius is going to be half of the rectangle that surrounds it. So if you think about that for a second, going from the outside of the square around the ball to the middle is going to be equivalent to the radius. Then this where I do get x plus radius and get y plus radius, that's going to give me the center of the circle. Remember, the xy is the upper left-hand corner. So to get to the center, you need to add the radii, the value here. You're going to need to add that. So you get the center of both. Once I have the center of each circle, I just do a distance formula. Okay, so this is difference in x values squared, difference in y values squared, and take the square root. Okay, Pythagorean theorem distance formula. I want to see if the distance between the centers of the two different balls is less than the sum of their radii. So if the sum of their radii is basically how far apart they are for each other. If the sum of the radii is bigger than the distance between centers, they're not intersecting. If they're closer than the sum of the radii, then they are intersecting. So you might want to take some time to digest this, but you're welcome to use it. Maybe I could draw a diagram if you're still having some trouble with it. But the result is that when I use this method, I'm going to get a more accurate detection of the collision. So if I run this now, we'll see. Oh wait, I never changed it, did I? I got to recompile and run. So now let's look at it again. See here now they're passing close by and it's not detecting. So they actually have to intersect. Remember, what I'm looking for now is that the center are not closer than two of the radii, which makes sense, right? Because the centers have to be double. The distance from one center to the next is basically, if they're touching each other just barely, the distance from one center to the next center is the radii of the first, the radius of the first plus the radius of the second. So this will give us a more accurate intersection detection in the case when I'm using two balls rather than rectangles. The rectangles are really simple. You can just use the intersects, but for balls to get accurate, it's a little more complicated. So just wanted to share that with you. Thank you.